Okay, so these questions, 1, 2, and 3, weren't from last night's homework, they were from the day before. Okay, so I'm going to do 1 and then 3, and then I'm going to do 2 last, just because some of you I've already gone over number 2 with. So when I get to 2, if it's on not on if it's on this video, you can just turn the video off. Okay, so first number 1 says a car and a motorcycle are at rest and are 1,000 meters apart. Okay, so here's my car, and here's my motorcycle up here. Okay, and they are 1,000 meters apart. And they're at rest, which means VI of the car is 0 and VI of the motorcycle is 0. They start towards each other at the same time on a level track. The car is accelerating at 3.7 meters per second squared. The motorcycle is accelerating at 4.4 meters per second squared. At what position will they pass each other relative to the car's starting point? Okay, so we don't know the time it's going to take for them to meet, but we do know that whatever that time is, it will be the same. Okay, so these are going to be the same. And we don't know how far each of them have traveled when they meet, but we do know that delta D of the car plus delta D of the motorcycle needs to equal 1,000 meters. So in these questions, what you're going to do first is get an equation for delta D of the car. So if we look, there's a VI, an A, and a delta T, so it has to be VI delta T plus 1/2 A delta T squared, and the VI is 0, so this whole term disappears. So delta D of the car will be 1/2 A of the car delta T squared. We can't find it though, because we don't know the time and we don't know the delta D. We have 2 unknowns. We can't solve that equation. So we go over to delta D of the motorcycle and we do exactly the same thing. Its delta D is going to be VI delta T plus 1/2 A delta T for the motorcycle. The VI is still 0 for the motorcycle. So this will be 1/2 A of the motorcycle delta T squared. But again, we can't solve this equation. We have 2 unknowns. The rule in math is if you have 1 unknown, you can solve it with 1 equation. If you have 2 unknowns, you can solve it with 2 equations. If you have 3 unknowns, you need 3 equations to solve. In this one, we have 3 unknowns. We don't know delta D of the car. We don't know the time. We don't know delta D of the motorcycle because the times are the same. But look, we have 3 equations. So we'll take our delta D of the car and plug it in this equation where delta dc is. So it becomes 1/2 A of the car delta T squared plus. And we'll take what our delta D of the motorcycle is equal to and we'll plug it in for it. So 1/2 A of the motorcycle delta T squared. Now your subscripts on the A are important because they're not the same A. You could multiply everything by 2 if you want to get rid of the 1/2. Equals 2,000. And now you want to solve for T squared. So we have to use that trick that we learned back when we were doing math at the beginning of the semester. Factor the T squared out. And what you'll be left with is A of the car from this term plus A of the motorcycle from this term will equal 2,000 meters. And now divide both sides by the bracket because you want the delta T by itself. Okay, so you'll be left with delta T squared is equal to 2,000 meters over A of the car plus A of the motorcycle. And now fill in your numbers. So 2,000 meters, and you're going to divide by A of the car is 3.7 meters per second squared, plus A of the motorcycle is 4.4 meters per second squared. So that's 2,000 meters divided by 8.1 meters per second squared. And when you do this, 8.1, you get 246.91 3, 5, 8, etc. seconds squared. And then you're going to take the square root. So you get delta t to be 15.713 seconds. It's not what the question asked, though. The question asked, at what position will they pass each other relative to the car's starting point? So we can go up here and find out how far did the car travel now that we have our time. So 1/2, 3.7 meters per second squared, times the 15.713 seconds squared. Squared times 3.7, and you get 456.79 meters, which is your answer. Now, if you wanted to double check, you could go over here and find delta D of the motorcycle. So 1/2, 4.4 meters per second squared, times that 15.713 seconds squared. And when you do this, you shouldn't get the same answer, but you get 543.21 meters. This number and what you found for the car, they should add together to give you 1,000. And check it out, they do. So that means you did it correct. Okay, that's number 1. Number 3, a student throws a ball vertically upward with the speed of 9.81 meters per second. Okay, so for the ball, so it's going straight up. So VI is 9.81 meters per second, and that's up. Another student, so the second part of the question is the other student who's standing over here, and they're going to run to catch it. Okay, another student standing, which means VI equals 0. 5 meters away, delta D is 5 meters. Starts to run towards the ball on release and catches it at the same height. What must be the student's acceleration? So we're looking for A. Okay, so on this side we have VI is 9.81 meters per second up. We have A is 9.81 meters per second squared down. And this ball is going to go up until it stops, until the VF is 0. So we can find the time that it takes to go up, right? We can do A is equal to VF minus VI over delta T. So delta T up will equal VF minus VI over A. And when it's up, the VF is 0. So delta T up will equal negative 9.81 meters per second. Negative because of the subtract. And then gravity goes in as negative 9.81 meters per second squared. And what we find out is that delta T up is 1 second. But it has to go up and come back down before the person catches it. So delta T total for the ball will be 2 seconds. And that means the student has 2 seconds to get over there to catch it. So what equation would you use if you have VI, delta D, and A? You would use delta D is equal to VI delta T, 1/2 A delta T squared. VI is 0. Rearranging for A, multiply both sides by 2, and then divide by T squared. So A equals 2 delta D over delta T squared. 2 times, he was 5 meters away, and the the time is 2 seconds squared. On the top, you get 10 meters. On the bottom, 4. 10 over 4 is like 5 over 2 is like 2.5 meters per second squared. And that's how far away you need to stand. Okay, so there is 1 and 3. I will do 2 in the next video because time is about to run out.